Hi, welcome back to my class in Algebra. For today, we will take up rationalizing an algebraic expression. To rationalize is to remove the radical sign from an algebraic expression. And today we will study how to rationalize the denominator of a given rational algebraic expression, as well as how to rationalize the numerator of a rational algebraic expression. For our first example, consider the following rational algebraic expression. This is an example of rational algebraic expression. We have square root of x minus square root of y all over square root of x plus square root of y. This algebraic expression is an example of rational algebraic expression because it is a ratio of two algebraic expressions. The algebraic expression in the numerator is a binomial, square root of x minus square root of y. The algebraic expression in the denominator is also a binomial that contains radicals, square root of x plus square root of y. First, we will rationalize the denominator. And to rationalize the denominator is to remove the square root from square root of x and to remove the radical sign from square root of y. That is to remove the radical signs from the denominator. And to rationalize the denominator, we multiply the given algebraic expression. To rationalize the denominator is to multiply the given algebraic expression by the conjugate of the denominator. Again, to rationalize the denominator is square root of x plus square root of y. We multiply the given rational expression by the conjugate of the denominator. Specifically, we multiply the numerator and denominator by the conjugate of the denominator. The conjugate of square root of x and square root of y plus square root of y is also a binomial with the first term square root of x and the second term is square root of y. Except that the sign between these two radical expressions or two radicals is not positive but negative. Square root of x minus square root of y is the conjugate of square root of x plus square root of y. Again, the conjugate of square root of x plus square root of y has the same first term is square root of x and the same second term is square root of y, except that the sign between the two terms is not positive but negative. If in the given rational algebraic expression you have square root of x minus square root of y, then its conjugate will be square root of x plus square root of y. If you have minus here, the sign between square root of x and square root of y is minus, then the sign between the two terms of the conjugate of square root of x minus square root of y is positive. In other words, the conjugate of square root of x plus square root of y is square root of x minus square root of y. And the conjugate of square root of x minus square root of y is square root of x plus square root of y. They are conjugate of each other. And to rationalize the denominator, we multiply the numerator and the denominator of the given rational algebraic expression by the conjugate of the denominator. So we multiply square root of x plus square root of y by its conjugate, which is square root of x minus square root of y. And we also multiply the numerator by the conjugate of the denominator, which is square root of x minus square root of y. Now we perform the multiplications at the right hand side, the multiplication in the numerator and the multiplication in the denominator. In the numerator, if you take square root of x minus square root of y as one quantity, its exponent is 1. Also, if you take square root of x minus square root of y as one quantity, its exponent is also 1. Now, to multiply these two, the common base is square root of x minus square root of y. Square root of x and square root of y minus square root of y is the common base. And to multiply these two, we apply property of exponent. This property of exponent says if you are multiplying exponential notations with the common base, the product of these two, a to the n multiplied by a to the m, is equal to the common base a. And the exponent of a in the product is the sum of the exponents of a at the left hand side, n plus m. In our example, the common base a is square root of x minus square root of y. And by this property, we add the exponents n plus m. We add 1 plus 1 is 2. In the denominator, we have the product of square root of x plus square root of y and square root of x minus square root of y. They are both binomials with the same first term is square root of x and the same second term is square root of y. But the sign between the two terms are positive and negative. We take the square root of x plus square root of y as one quantity and we multiply that by the second quantity and we apply a special product rule for the product of a sum and difference. This is the special product rule for the sum and difference of two terms. The first terms are the same, the second terms are the same, and the sign between the two terms differ. One is positive, the other is negative. That's why this rule is called the product of a sum and difference. And the product of a plus b multiplied by a minus b equals the square of a, the first term, minus the square of b, the second term. In the denominator, square root of x is our a, square root of y is our b. And by this special product rule, the product of square root of x plus square root of y multiplied by square root of x minus square root of y is equal to the square of square root of x minus the square of b, the second term is square root of y. We simplify further. To get the square of this binomial, the difference of square root of x and square root of y, we apply another special product rule for the square of the difference. The special product rule for the square of the difference, a minus b is equal to the square of the first term minus twice the product of the two terms, or minus 2 times the product of the two terms plus the square of the second term b. In the numerator, square root of x is our a, square root of y is our b. And applying this special product rule to the numerator, the square of square root of x minus square root of y is equal to the square of the first term, square root of x square minus twice the product, or 2 times the product of the two terms. It's always 2. It's always minus 2. For the square of a difference, it's always minus 2. The middle term is minus 2 times the product of the two terms. Square root of x multiplied by square root of y. And the third term is always positive. The square of the second term is square root of y squared. For the denominator, we take the square of the square root of x, and we apply property of radical and property of exponent. In the square root of x, the radicand is x and the exponent of x is 1. And for the square root, the index is understood to be 2. If the index is not shown or is not written, it is understood that the index is 2 for square root. And we apply this property of radical. By this property of radical, we can remove the radical sign and write the given radical expression as an expression with a rational exponent n over m, where the numerator n is the index of the radical sign and m is the exponent of the radicand a. Applying this property of radical, square root of x to the 1 equals x raised to exponent of x is 1. And for the square root, the index is 2. And raised to the power 2. Minus, we apply again this property of radical to the square of square root of y. For the square root, the index is 2. The radicand is y, and if you write the exponent of y is 1. Hence, square root of y is, by this property, can be written as y raised to 1. Divide by the index of the radical sign. For square root, the index is 2. And raised to power 2. And to simplify each term in the denominator, we apply again another property of exponent. This property of exponent says that if a to the n is raised to another exponent m, Then a to the n raised to m is equal to a, the base, and the exponents are multiplied and multiplied by m, or nm. We apply this property of exponent to each term in the denominator. We multiply 1/2 by 2, so x is raised to 1 multiplied by 2 is 2 divided by 2. 2 divided by 2 is 1. Minus y 1/2 multiplied by 2 by this property of exponent. 1 multiplied by 2 is 2 divided by 2. 2 divided by 2 is 1. In the numerator, first term, the square of the square root of x can be simplified using again this property of exponent. The index is 2, the exponent of x is 1. Hence, by this property of radical, the square root of x raised to 1 is equal to x raised to its exponent 1 divided by the index of the radical sign 2 and raised to exponent 2 minus 2. Now, square root of x and square root of y have the same index 2. And another property of radical says that if you are multiplying two radicals with the same index, they can be written as a single radical. In particular, this property of radical says that the nth root of A multiplied by the nth root of B is equal to the nth root of the product AB. The first radical index is n. The second radical, the index is also n. And they have different radicals. And this property says that the product of these two radicals can be written as a single radical whose index of the radical sign is the common index of these two factors, and the radicand is the product of the radicals in these two radicals. So we apply this property of radical to multiply square root of x square root of y as a single radical. The index is 2. The index of square root of x is 2. The index of square root of y is 2. The common index is 2 or square root of 2. And we multiply the radicals x multiplied by y. Plus, to simplify the square of square root of y, we again apply this property of radical. Square root of y, for square root of y, the index is 2, and the radicand is y. If you write the exponent of y, it is 1. So the square root of y raised to 1 can be written by this property of radical as y raised to its exponent 1 divided by the index of the radical sign 2, and y raised to 1/2 is raised to the power 2. We simplify further. We simplify the square of x raised to 1/2 by this property of exponent. We multiply the exponents n and m. We multiply 1/2 by 2, and we get x to the power 1/2 multiplied by 2 is 2 over 2 or 1. But if the exponent is 1, we no longer write the exponent 1. Hence, x raised to 1/2 square is simply x. minus 2 square root of xy plus, again, to simplify the square of y raised to 1/2, we apply this property of exponent. We multiply the exponents n and m, multiply 1/2 by 2, and we get y raised to 1/2 multiplied by 2 is 2 over 2 or 1. Hence, the square of y raised to 1/2 is y raised to 1. But if the exponent is 1, we do not write 1 anymore. All over x raised to 1, we simply write x minus y raised to 1. We simply write y raised to 1 as y minus 1. Hence, we have removed the radical signs in the denominator, square root of x plus y. Now, this rational algebraic expression is square root of x minus square root of y all over square root of x plus square root of y is the same as this rational algebraic expression x minus 2 square root of xy plus y all over x minus y. The only difference is that in this rational algebraic expression, we do not have anymore the radical signs. We have removed the radical sign, the square root from square root of x, and the radical sign from square root of y. We take a second example in which we will now rationalize the numerator of the given rational algebraic expression. Consider again this rational algebraic expression, the same rational algebraic expression in number 1, square root of x minus square root of y all over square root of x plus square root of y. In the first example, we rationalized the denominator, and we did that by multiplying the numerator and the denominator of the given rational expression by the conjugate of the denominator. And we said that the conjugate of two terms is obtained by simply taking the opposite side of the sign between the two terms. Hence, the conjugate of square root of x plus square root of y is square root of x minus square root of y. To rationalize the numerator here, square root of x minus square root of y, we multiply the numerator and the denominator again. To rationalize the numerator, square root of x minus square root of y, we multiply the numerator and denominator of the given rational algebraic expression by the conjugate of the numerator by the conjugate of square root of x minus square root of y. The conjugate of square root of x and square root of minus square root of y has the same first term and second term, square root of x and square root of y. But the sign between them is positive instead of negative. So we multiply this numerator and denominator by the conjugate of square root of x minus square root of y. The same terms, square root of x, square root of y, but the sign between them is positive. We also multiply the denominator by the conjugate of x, square root of x minus square root of y, which is square root of x plus square root of y. And we multiply the numerators and the denominators applying properties of radicals and properties of exponents. In the In the numerator, we have a product of a sum and difference. They have the first term, they have the same second term, except the sign between the terms are opposite, one positive and one negative. Hence, to multiply the numerators, we apply the special product rule for the product of a sum and difference. Given by this rule, the product of a plus b and a minus b is equal to the square of the first term a minus the square of the second term b. In the numerator, our a is square root of x and our b is square root of y. By this special product rule, the product of square root of x minus square root of y multiplied by square root of x plus square root of y is equal to the square of square root of x. Minus the square of b. Our b is square root of y. Square. In the denominator, we are multiplying two binomials to the same binomials, square root of x plus square root of y, multiplied by the same binomial, square root of x plus square root of y. And if you take square root of x plus square root of y as one quantity, and you write the exponent is 1. Similarly, if you take square root of x plus square root of y as one quantity, and you write its exponent, the exponent is 1. And to multiply these two, the common base now is square root of x plus square root of y. We apply this property of exponent, a raised to n multiplied by a raised to m. The common base is a, and the exponent of a in the product is the sum of the exponents of a at the left hand side, n plus m. We apply this property of exponent, we multiply square root of x plus square root of y raised to 1 by the quantity square root of x plus square root of y raised to 1. Copy the common base, square root of x plus square root of y. And add the exponents. 1 plus 1 here is 2. We simplify the numerator and denominator. For the first term of the numerator, we have the square of square root of x. For the square root, the index is understood to be 2. And if you write the exponent of x, its exponent is 1. The same with the square root of y. For square root, the index is 2. And the exponent of y, if you want to write it, is 1. And the square root of x raised to 1, using this property of radical, the nth root of a to the m equals a raised to a rational exponent whose numerator is the index of the radical sign, and the denominator m is the exponent of a. And we use this property of radical to remove the radical sign. Hence, the square root of x raised to 1 by this property of radical is x raised to 1 divided by the index of the radical sign. For square root, the index is 2. Raised to the power 2. Square root of x raised to 1 is x raised to 1 half. And we still have to raise that to power 2. Minus, again we apply this property of exponent to square root of y raised to 1. By this property of, radical, square root of y raised to 1 is equal to y raised to 1 divided by the index of the radical sign 2 raised to the power 2. In the denominator, we have the square of a sum of two terms or square of binomial. And we apply another special product rule. This is the special product rule for the square of a difference. For the square of a sum, the sign between A and B will be positive. The square of a sum, A plus B is equal to the square of A, the square of the first term. The middle term now, instead of negative, will be positive for the square of a sum. So this will be plus 2 times the product of the two terms. And the last term is positive. The square of the second term B, the square of B. For the square of a sum, the middle term is positive 2 times the product of the two terms. In the denominator, our A is square root of x and B is square root of y. And the square root of x plus square root of y equals the square of A, the square of the first term is square root of x plus 2 times the product of the two terms plus 2 times the product of these two terms is square root of x multiplied by square root of y. And the last term is positive plus the square of the second term b. The square of the second term is square root of y. We simplify further the numerator and denominator. For the first term in the numerator, the square of x raised to 1/2, we apply this property of exponent. A raised to n and raised to the power m is equal to a raised to the product of the exponents n and m. So to get the square of x raised to 1/2, multiply the exponents 1/2 multiplied by 2. And 1/2 multiplied by 2 is 1. Hence, the square of x raised to 1/2 will be x raised to 1 minus, again, by this property of exponent, we take the square of y raised to 1/2. We multiply the exponents 1/2 and 2. 1/2 multiplied by 2 is 2 over 2 or 1. Thus, the square of y raised to 1/2 is y raised to 1. In the denominator, first term, we simplify the square of square root of x. If you write the exponent of x, it is 1. The index for square root is 2. This, to simplify the product of square root of x and square root of y, we apply this property of radical. The nth root of a multiplied by nth root of b can be written as a single radical expression, as an expression with a single radical sign whose index is the common index n, and the radicand is the product of a and b. And for the third term, we apply this property of radical, where the exponent of y is 1 and the index of the square root is 2. Hence, by this property of radical, the square root of x raised to 1 equals x raised to 1 divided by the index of the radical sign 2, and x raised to 1 is raised to the power 2, plus 2. Here we can write square root of x times square root of y as a radical expression with a single radical sign, square root. The common index is 2 for square root. That's why we have square root here. And the radicand is the product of x and y by this property of radical. Plus square root of y raised to 1 is y raised to 1 divided by the index of the radical sign 2 raised to the power 2. Now we remove the exponents 1 from x and y, because if the exponent is y, we no longer write 1. And the numerator, we simply write x minus y over, we have x raised to 1/2 raised to 2. To simplify, we apply this property of exponent. We multiply the exponents 1/2 and 2. 1/2 multiplied by 2 is 2 over 2, which is 1. Hence, the square of x raised to 1/2 is x raised to 1. Or we simply write x plus 2 square root of xy plus for the square of y raised to 1/2, we apply this property of exponent. We multiply the exponents n and m. We multiply 1/2 by 2. Thus, the square of y raised to 1/2 is equal to y to the power 1/2 multiplied by 2 is 2 over 2, which is 1. Or y raised to 1, we simply write y. Now we have rationalized the numerator, square root of x minus square root of y. That is, we have removed the radical sign from square root of x and from square root of y. The numerator now does not contain any radical expression or radical sign. But the given rational expression, square root of x minus square root of y, all over square root of x plus square root of y is the same as this rational algebraic expression x minus y all over x plus 2 times square root of xy plus y. Except that in this rational algebraic expression, the numerator does not contain any more radical expression or radical sign, because we have rationalized the numerator of the given rational algebraic expression. For your practice, please try the following exercises. For letter A, rationalize the denominator. In number 1, the given is 1 plus square root of x all over 1 minus square root of x. And you will rationalize the denominator 1 minus square root of x by multiplying the numerator and denominator by the conjugate of the denominator. In number 2, the given is the rational expression square root of y minus 3 over square root of y plus 3. We will rationalize the denominator by multiplying numerator and denominator by the conjugate of square root of y plus 3. In number 3, the given is square root of 2m plus square root of n all over square root of 2m minus square root of n. Again, you will rationalize the denominator, multiply the numerator and denominator by the conjugate of the denominator, conjugate of square root of 2m minus square root of n. For you to be able to check your answers, I give you the answers to letter A, where you will rationalize the denominator. For number 1, the answer is 1 plus 2 square root of x plus x all over 1 minus x. For number 2, the answer is y minus 6 square root of y plus 9 all over y minus 9. For number 3, the answer is 2m plus 2 multiplied by square root of 2mn plus n all over 2m minus n. The second part of your exercise is rationalizing the numerator. Letter B, rationalize the numerator. In each of these numbers, 1, 2, 3, you have the same given rational algebraic expression as in part A, except that in part B of your exercise, you will now rationalize the numerator. In number 1, the given rational algebraic expression is 1 plus square root of x over 1 minus square root of x. But you will rationalize the numerator by multiplying the numerator and the denominator by the conjugate now of the numerator, conjugate of 1 plus square root of x. In number 2, you have square root of y minus 3 all over square root of y plus 3. And you will rationalize the numerator, square root of y minus 3. So you multiply the numerator and denominator by the conjugate of square root of y minus 3. In number 3, you have square root of 2m plus square root of n all over square root of 2m minus square root of n. You will rationalize the numerator 2m, square root of 2m plus square root of n. You multiply the numerator and denominator by the conjugate of the numerator, square root of 2m plus square root of n, its conjugate. And again, for you to be able to check your answer, I give you the answers to part B of your exercises. For number 1, the answer is 1 minus x over 1 minus 2 square root of x plus x. For number 2, the answer is y minus 9 all over y plus 6 square root of y plus 9. And for number 3, the answer is 2m minus n over 2m minus 2 times square root of 2mn plus n. In the next lesson, we will take more examples for rationalizing an algebraic expression. But in the next examples for rationalizing an algebraic expression, we will have radical expressions where the indices are more than 2. You notice that in our examples for today for rationalizing an algebraic expression, all the indices are 2. In the next lesson, we will have examples where we will rationalize radical expressions whose indices are more than 2. If you have questions about the lesson today, please ask your questions in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison, the channel of learning and pleasure. You may also ask your friends and classmates to subscribe to my YouTube channel, Art Kalison, and learn for free. I will be your tutor for the whole course of algebra. Thank you for being in my class today.